Welcome back to Code and Current Studio. In this episode, we're taking our LED project to the next level by adding a distance sensor. Now, the LED will blink when an object is nearby or when you press the button manually. This project introduces real-world sensing, conditional logic, and dual point control. From our previous project, we have the LED connected to pin 13 and the push button connects to pin 2. The HC-SR04 distance sensor connects as the following: VCC to 5V, ground to ground, TRIG to pin 9, and echo to pin 10. This setup allows the Arduino to measure distance and respond accordingly. Alright, first we'll add the distance sensor. Trigger to pin 9, echo to pin 10, VCC to the 5-volt source, I'm going to take this wire and move it down just a little bit. All of these circuits on these pins will be connected to 5 volts. And ground will go to ground. Clean this up a little bit. In this project, we're building on what we've already covered with the LED and the push button steps. We'll reuse that code and expand it to include a distance sensor. To keep things clean and organized, we'll define our pin assignments using const int variables. This makes our code easier to read and ensures that those values stay fixed throughout the program. For the sensor's output, we'll be using the long data type. This allows us to store larger, more precise values, perfect for capturing accurate distance measurements. And to visualize the sensor's data in real time, we'll initialize serial communication using serial.begin. This lets us monitor the sensor's output directly in the serial monitor, which is a great way to verify everything is working as expected. Okay, let's adjust the code. First, we'll introduce the constants as integers. That establishes our trigger pin as an output. That establishes the echoPin as an input. And then we will start the serial. In our loop, we'll introduce our long. So we'll need one for duration, and one for distance. That will reset the trigger. That will stabilize the sensor. That will be the high pulse. That will be the pause. That will turn the trigger pin off. That will measure the echo return time. That will convert the duration into distance, centimeters. And that will print the distance in the serial monitor. We're going to reuse most of our conditional code. I'm going to change it just a little bit. To read if the distance is less than 10 or the digital read equals high, which is going to say if the button is pressed. So if the distance is less than 10 or the button is pressed, the bulb will blink. And we're going to make it flash a little bit faster by changing these from 1000 to 250. So instead of being 1 second, it'll be a quarter of a second. If we place an object near the sensor, if it's within 10 centimeters, the LED will blink. You can also press the button manually, triggering the blinking. This dual input setup is great for testing and adds flexibility to your circuit. We can monitor the sensor using the monitor display. If you're following along and want to build this for yourself, I recommend grabbing an Arduino starter kit. Most kits come packed with everything we've used today, plus a few extras like sensors, buttons, resistors to keep you experimenting. You'll find the link in the description below, along with some additional components if you're looking to expand your setup. Nice work, you've just combined real-world sensing with manual control, an essential when making your Arduino projects interactive and responsive. In the next video, we'll take things further by adding a buzzer to the circuit and walking through how to diagnose a fault in your wiring. If you found this helpful, please be sure to like and subscribe and explore the links in the description for parts, codes, and bonus resources.